The electric potential in a region around the origin is given by Vx equals to 4x square. The electric charge enclosed in a cube outside 1 meter side, which is center at the origin, is okay. So we have to calculate the electric charge enclosed in a cube of 1 meter, and it is said that the electric potential in a region around the origin is given by B equals to 4x square. So electric potential is given, we have to calculate the total charges. So I will write the value of electric field from here. E will be how much? That is minus of del V by del X. Okay, because potential is a function of X only. So charge is distributed over the X axis only. So E will be how much? That is minus of 8x. Electric field we got here as minus of 8x. Now uh, it is said that this is our axis, and the electric charge enclosed in a cube of side 1 meter at its center at the origin is. So this is a square at the origin, and the cube of side 1 meter, this is the center of the cube here. This is our center that we have considered. Now if we calculate the flux through this region, then phi flux through this region, if I calculate, then phi outside, that is how much here, because electric field is negative. So electric field negative means I can say that the flux will be negative here, because uh, electric field will be in this direction at this side, and it will be in this direction because E is equals to minus of 8x is given. This is x equals to half meter here, and this is minus of half meter. So if I calculate phi total, then phi total will be, because here also flux is negative through this face, here also flux through this face is negative. Remember, this is a square. So phi total will be written here as E into area, and the electric field that we have here, exactly same electric field we have here also. So E times area. So area is a square multiplied with 2, and this will be with negative sign, because this face E a square, this face a square, and then negative sign. So minus 2e times a square. Now we can substitute the value 2 times e. Flux at this is 8 into x is basically half here, so times 1. So this is minus of 8, and that should be equals to q enclosed by epsilon naught. So from here we will get q enclosed equals to minus of 8 epsilon naught. So the correct answer should be option third here. We got the electric field, and once we got the electric field, then we can get this one also. Or if you could use the differential form of the Gauss law, then E is equals to minus of 8x. So we can write del E by del x here, del E by del x. That will be equals to rho by epsilon naught. So if you solve it, del E by del x, here remember charge is distributed over the length. So instead of rho, we will get linear charge density, that is lambda. So here we will get lambda here. Then if I write here del E by del x, so del E by del x is how much? Del E by del x is nothing but that is 8 minus of 8 here. Del E by del x we will get here minus of 8. Now these two equation I can equate them together. So lambda by epsilon naught equals to minus of 8, and lambda we will get here minus of 8 epsilon naught. So in either way we can solve this problem.